Okay, so the next topic is 1.3, which is chemical equations. The first learning outcome is that you have to learn how to deduce chemical equations when all reactions and products are given. And for some reason, in this topic, you also have to learn what subscripts are and what coefficients are. And this is what you have to use to learn how to balance the equations. So the subscripts, that's the small number that's like put down to the right of the atom, which shows how many atoms there are in each molecule. So here in the first example, you have 2 hydrogen atoms in water. The coefficients are in front of the molecules, which shows how many molecules you have. So here the 2 represents that you have 2 water molecules, each containing 2 hydrogen atoms. So that means in total you have 4 hydrogen atoms. And the same counts for the iron oxide I've shown here. Okay, so if you know that the reactions of a chemical equation are oxygen gas and hydrogen gas, and that the product is water, you draw an arrow to show that the reaction goes from left to right. To balance the equation, first look at reactions. You know that you have 1 oxygen atom and 2 hydrogen atoms. Then add the coefficients in front of the oxygen and hydrogen to make it work. If you take half oxygen molecule, you get 1 oxygen atom. And since we don't like fractions in our chemical equations, you have to multiply everything by 2, which is why you get 1 oxygen gas molecule, 2 hydrogen molecules, will result in 2 water molecules if this reaction is let to run forward.
The next point in this is 1.3.2, and you have to identify the mole ratio of any 2 species in a chemical equation. So the first example we'll look at is oxygen plus 2 hydrogen gives 2 water. And the ratio between this is the numbers in front of the reactions and the products. So we know that it's 1 oxygen and there's 2 hydrogen and 2 water. So it'll be a 1 to 2 to 2 ratio. Okay, the next example is calcium oxide mixed with water. That will give calcium hydroxide. Yeah, and the ratio between these will be 1 to 1 to 1. So it'll simply be a 1 to 1 to 1 ratio, which is very, very easy.
Okay, so the next topic we'll look at is how to apply the state symbols, where S is a solid, L is a liquid, G is a gas, and AQ is an aqueous solution. And these state symbols, they're written as subscripts next to the subscripts that indicates the amount of atoms in the molecule. So for example, if you take the reaction between oxygen and hydrogen again, where we produce water, at standard states, oxygen is a gas, so is hydrogen, but the water is liquid. That means that we have 2 gases and they react to form a liquid, which is water. But if this reaction is run above 100 degrees centigrade, you will have oxygen and hydrogen still as gases, but the water would also be a gas, because water boils at 100 degrees centigrade. And if you have to look at aqueous solutions, that is when you dissolve something in water. And when you dissolve something in water, if you look at the previous example where calcium oxide reacts with water, you would get an aqueous solution of calcium hydroxide, because when the calcium hydroxide is dissolved in water, you get calcium plus ions and 2 hydroxide minus ions.